there's an equal sign, so it's an equation. So if it equals 0, you are looking for the x-intercepts of the parabola. If it equals 0, you are looking for the x-intercepts of the parabola. So from Monday, what other names did we give to these x-intercepts? The zeros. You see now why they're called the zeros? Because that's where it equals 0. A bunch of brainiacs came up with this. The x-intercepts, these are also going to be called the zeros. What else do I have written down? The roots. That's going to tie into what we're getting into also. It's called some factors, or the roots of the factors. And what do we usually call just any answer to an equation? The solutions. So the zeros, that kind of ties into what we're doing here. The roots, we'll talk about that a little bit more later on, but these are also called the solutions. Okay. So we can have 3 types of solutions. We saw this a little bit earlier. We have that sort of graph. That sort of graph. That sort of graph. So we have 3 types of solutions. I have 3 types of graphs up there. I'll give you a moment to write those down. So instead of saying 3 types of solutions, I could have said 3 types of what? Zeros. 3 types of roots. 3 types of, I said solutions, x-intercepts. So how many x-intercepts do I have on this first one? So how many real solutions do I have? So you could have 2 real solutions. So if you have 2 real solutions, let's say this is at 1 and this is at -5. We would say x1 equals -5, x2 equals 1. Because we have 2 solutions, we have 2 different x values that are the answer. Now in this case, the second one, the graph is going to come down, it's going to touch the x-axis, and then it's going to go back up. So how many solutions do we have here? 1. So we have 1 real solution. So since we just have 1, we could say x equals 2. That's the number 2 right there. So you don't really have an x1 and an x2, you just have x equals 2. That's actually what they would call a double root. And the third one doesn't have any x-intercepts. So we're going to say no real solution. I want you to put that word real in there because coming up, maybe before Christmas, maybe not, we're going to cover imaginary solutions also. Because this one has imaginary roots. These are real roots when it really crosses the x-axis. And if all the real numbers weren't enough for you, we're going to throw all the imaginary numbers in there too. Exciting stuff. It's not as bad as what you think it is. can be challenging too. Okay. Okay, so they're going to say solve x squared minus 3x minus 4 equals 0 by graphing. Calculators. Unless you want to graph it by hand. If you want to do that, you're welcome to do that. Sometimes this would be a time we prefer the piece of plastic to work for us. So we're going to graph y equals x squared minus 3x minus 4 on the calculator. You may need to go back to your standard window, that'd be Zoom 6. So you type it into the y equals and then go Zoom 6. That'll take you back to your standard window in case it's all messed up from other things. Zoom 6, Zoom standard. So Zoom down to 6, Zoom standard. Are you getting my picture? Yeah. Standard? Yes. Okay, so what are we looking for here? X-intercepts. So the first thing you want to do is you want to check the table for any x-intercepts. Now you can look at the graph and you can probably guess, hey, it looks like it's going to be -1 and 4. But how do you know if it's -1 or if it's -0.98? Okay, the graph's not going to tell you that. So we're going to check our table. And if it's an x-intercept, it's an x-intercept when y is 0. Okay, so that's what you're looking for. Now, when I go to my table, I'm clear up here. You remember how to change your table around? Table setup. Table setup. So second window, and I want to start my table down around 0, or maybe even -1, because that's what I'm guessing is my x-intercept. Okay. So you see those right there? So -1 is 0, and then 4 is 0. So how many real solutions do I have? 2. So you'd say x1 equals -1, x2 equals 4. Those are your roots, those are solutions, that's the answer to the question. Okay. We're going to do some where it doesn't work out so nicely and you can't tell from the table yet. The calculator is going to do that for us as well, though. Yep. Minus zeros. Yes, Dawson. What? What'd you do to it? Okay, hang on. Let's do... x squared plus 2x minus 7 equals 0. Okay. Okay, you have to tell it to start on a normal number. You switch this back to counting by 1, but this was set at 0. So if it was starting at that, we would know that it's counting by 1. Okay, I made up these numbers, so did it work out for us at all? Well, okay. we have two real solutions. It's crossing.
I didn't actually look at the graph.
You want to look at the graph. Also, when you look here, in between -4 and -3, it's positive and it's negative. So if you go from positive to negative, guess what number you have to go through? So is there a 0 in there? Yes. Now, is it -4 or -3? It's something between those two. Same thing down here. It's negative, and then it's positive. So it has to be a 0 in between 1 and 2 as well. Okay? So, using the calculator to do this, we're going to go back to the calculate menu. So we want to calculate, and guess what we want to calculate? The zeros! Yay! This is going to be look very similar to yesterday. So we want to calculate, and then you're going to press option 2, a 0. And we'll have to do this twice because there's 2 zeros in there. So we're going to calculate a 0, we select that, and guess what it asks us for? Left bound. So I'm going to do this 0 over here first. Okay, we're going to have 2 zeros. You have to do one at a time. So I'm going to go do this one first. You don't have to do this one first. But if I do a left bound, the left side of this 0 is going to be up here. Okay, so use your left and right arrows. You have to be left of your 0. Press enter. Then it asks for right bound. In this case, it's going to be below the x-axis. You see my triangles up here? So the calculator is going to look between those 2 triangles for the x-intercept. And let's round to the hundredth. Does it say specifically at all? Okay. So you have to do left and right bounds. Then you press enter a 3rd time. So are we getting this negative 3.83? Yeah? Okay. So that's x1. Now we have to find our second x. We just go do the same thing, only we're going to do it over here now. So second trace, calculate the 0. But now my left bound is going to be below the x-axis because it's an increasing function. My right bound will be above because it's an increasing function. They'll always be kind of like that. Your decimals will be very similar once you start looking at the pattern of what's going on. And we will understand more of why that happens in later lessons. What? It is symmetric. These are going to be irrational roots. These roots include some sort of square root. And we are working towards finding these and finding exact answers. These are going to be rounded answers. So this answer is probably something like 2 plus the square root of 3, and 2 minus the square root of 3. Yeah. Okay. Now, the book is going to state, they're going to ask you to do this. If exact roots cannot be found. So what they're saying here is